Good morning, all of you. In this session, I am going to explain about design of longitudinal and circumferential joints for boilers. And also, I will explain about simple problems on design of boiler joints. Before going into the problems, first of all, we have to know the fundamentals about types of failures. Here, these are the important formulas used in longitudinal riveted joints. Here, sigma T is the tensile, permissible tensile stress induced in the plate material. Sigma C is the permissible crushing stress for a plate material or rivet. Tau, tau is the permissible shear stress in rivets. D, small d is the diameter of the rivet. Capital D is the diameter of the boiler. Capital D is the diameter of the boiler. Okay, small d is the diameter of the rivet. Small d is the thickness of the plate. P is the pitch of the rivets. M is the margin. Okay. Now, PT is the tearing strength. Okay, the rivet may fail due to tearing of the plate across the row of rivets. So, to resist that failure, you have to use this formula. Okay, tearing strength PT equal to P minus D into T into sigma T. Here, sigma T is the tensile stress, T is the thickness of the plate, D is the diameter of the rivet, P is the pitch of the riveted joint. Okay, pitch of the rivets. In a similar way, the joint may fail due to crushing. Okay, so this is the crushing strength. The PC is the crushing strength for a riveted joint is equal to N into D into T into sigma C. Here N is the number of rivets used for joints. N equal to 1 for a single riveted joint, N equal to 2 for the double riveted joint, N equal to 3 for triple riveted joints. Okay. So sigma C is the compressive stress or crushing stress. And the last one is the shearing strength. The riveted joint may fail due to shearing of the rivet. Okay. Here, for all type of lap joints and single cover butt joints. Okay. For all type of lap joints and single cover butt joints, you have to consider single shear. Okay. For all type of lap joints and single strap butt joints, you have to consider single shear. Okay, this is the formula for single shear. Okay, shearing strength. Shearing strength PS equal to N into pi over 4 d square into tau for single shear. Okay, single shear for all type of lap joints and single strap butt joints. And these are the formulas for double shear. Okay, this is a theoretical value. Okay, so this is the actual double shear value for boilers. Okay, 2 into N into pi over 4 d square into tau for double shear for all type of double cover butt joints, double strap or double cover butt joints. Okay, this is a theoretical value, but you have to use this value for boilers. PS equal 1.875 into N into pi over 4 d square into tau for double shear for boilers. For design of boiler joints, you have to use this formula. Okay, and these are the number of rivets per pitch. Okay, N equal to 1 for a single riveted joint, N equal to 2 for double riveted joint, N equal to 3 for triple riveted joint, N equal to 4 for a quadruple joint. Okay. Now these are the important formulas: PT, PC, PS. These three are the important formulas for design of longitudinal and circumferential joints. Okay. Now, if you want to determine the efficiency of the joint, this is the formula for efficiency. Efficiency zeta equal to least value of tearing strength, shearing strength, and crushing strength divided by strength of a unriveted plate, that is P into T into sigma T is the strength of the unriveted plate. Okay, by using this formula you have to determine the efficiency of the riveted joint. Okay, now this is the formula for thickness of the boiler shell. From this formula you have to determine the suitable thickness of the boiler shell. Okay, in this equation you have to consider 1 mm for corrosion elements. Okay, zeta L is the longitudinal joint efficiency, P is the maximum inside pressure, in the cylinder or boiler. Okay, capital D is the diameter of the boiler. Okay, small t is the thickness of the boiler shell. Okay, now diameter of rivets. For determining the suitable diameter of the rivet, we have to use D equal 6 root T formula for when thickness of the boiler shell is greater than 8 mm. Okay, when the thickness of the boiler shell is greater than 8 mm, then you have to use D equal 6 root T value. When the thickness of the boiler shell is less than 8 mm, then you have to equate shear strength and crushing strength for determining the value of D. From these two equations, you can get the value of diameter of the rivet D when P is less than 8 mm. Okay, this is the formula for crushing strength, and these are the formulas for shearing strength. For single shear, you have to use this formula. For double shear, you have to use these two formulas. Okay, for boiler joints, you have to use this last formula. Okay, so this is the standard dimensions table. From this table, you have to select the standard size of the rivet and rivet hole. Okay, for determining the pitch of the rivets, you have to equate these two equations. Okay, from these two equations, you can get the value of pitch of rivets. Okay, PS is the shearing strength, PT is the tearing strength. Okay, PT is the tearing strength, PS is the shearing strength. Okay, from these two equations, you can get the value of pitch of the rivets. Okay, now for checking the maximum pitch of the rivets, you have to use this formula P max equals C into T plus 41.28 mm. Here C is the constant. The value of constant you have to select from standard table. This is the table for selecting the value of C. Okay. Now coming to the example problem. This is very important question. Okay, for exam point of view. The given question is a steam boiler is to be designed for a working pressure of 2.5 megapascal with its inside diameter 1.6 meters. Give the design calculations for the longitudinal and circumferential joints for the following working stresses for steel plates and rivets. In tension 75 megapascal, in shear 60 megapascal, in crushing 125 megapascal. Draw the joints to a suitable scale. Okay, this is the diagram. You have to draw this diagram after getting the values. Okay. First of all, you have to identify the given data from the given question. Okay. So here you can observe you have to design a boiler. Okay, working pressure, this is the maximum inside pressure, that is P dash. Maximum inside pressure in the boiler equal to 2.5 megapascal, and the diameter of the boiler, that is capital D, diameter of the boiler capital D is 1.6 meters, and the design here, design calculations for longitudinal and circumferential joints. You have to design longitudinal and circumferential joints. Here, these are the stresses: sigma T, tensile stress, and this is the tau, shear stress, and this one is the crushing stress, sigma C. Okay. So here these are the given values. Maximum inside pressure P equal 2.5 megapascal. Diameter of the boiler shell equal 1.6 meters, that is 1600 mm. And tensile stress sigma T equal 75 megapascal. 1 megapascal equal to 1 Newton per mm square. Shear stress tau equal to 60 megapascal. Crushing stress sigma C equal to 125 megapascal. Okay, these all are the given values. By using these values, you have to determine you have to design a boiler joint. Okay, longitudinal and circumferential joints. In first case, I am going to design a longitudinal butt joint. Okay, here this is the formula for selecting the suitable thickness of the boiler shell. Here small t is the required thickness of the boiler shell. T equal to maximum inside pressure into diameter of the boiler divided by 2 into sigma t. Sigma t is the tensile stress for boiler material, plus 1 mm is the corrosion allowance. 1 mm is the corrosion allowance. Okay, so this is the value of thickness, required thickness of the sheet. Metal sheet thickness is 25 mm. Okay, in second step, you have to determine suitable diameter of the rivets. So here our thickness of the sheet is 28 mm, that is above 8 mm. Okay, so you have to use this formula D equal to 650. When the thickness of the boiler shell is greater than 8 mm, you have to select this formula. Okay, so from this formula, the diameter of the rivet equal to 31.75 mm. Okay, this is our required diameter of the rivet, but you have to check this value with the standard table. Okay, this is the standard table. From this table, you have to select standard diameter of the rivet and rivet hole. Here you can observe 31.75 is our answer. Okay, from this table, you have to select a nearest value 31.75. Here, this is the 30, this is the 33. So here the nearest value to 31.75 is 33. So this is the nearest value, and this is the corresponding size of rivet hole. Okay, from this table I selected these two values. Okay, these two are the nearest values for diameter D equal to 31.75. So the standard diameter of the rivet equal to D equal to 33 mm is the standard diameter of the rivet, and 34.5 mm is the rivet hole diameter. Okay, now coming to the third step, that is pitch of rivets. For determining the pitch of rivets, you have to equate these two values. Here you can observe pitch means the distance between two successive rivets. Okay, the distance between two successive rivets is called pitch. Okay, now here for determining the value of pitch, you have to use these two values, that is PT and PS formulas. This is the value of PT, that is the tensile strength or tearing strength. Tearing strength PT equal to P minus D into T into sigma T. Here the value of P is unknown. You have to determine that value. So this is the value of tearing strength. And here you can observe from this diagram, you can observe the riveted joint is a double strap butt joint. Okay, double strap butt joint. Therefore, 5 rivets per pitch length. Okay, 5 rivets per pitch length. So out of these 5 rivets, 4 are in double shear, 1 in single shear. Okay, so you have to consider double shear formula for boilers, and you have to consider double shear for 4 rivets and 1 rivet for single shear. Okay, from here to here, this is the double shear for 4 rivets, and this is the formula for single shear for single rivet. Okay, so this is the formula for PS. Okay, and this is the final value for shearing strength. Okay, this is the shearing strength of the joint. Now, now equating these two equations, equation 1 and 2, you can get the value of pitch. Here the pitch P equal to 261.5 mm is the pitch. Okay. Now after that you have to determine the maximum pitch of the rivet. This is the formula for determine the maximum pitch. P max equals C into T plus 41.28 mm. Okay. Here capital C is the constant. Okay. You have to select the value C from this table. Okay. Here here number of rivets per pitch is 5. Okay, 5 rivets per pitch. So you have to select this value 5 and the corresponding value for a double strap butt joint is 6. Okay, so 6.00 is the value of C for double strap butt joint with 5 rivets per pitch. Okay, so you have to substitute the value of C in this equation. You can get the value of maximum pitch. Here the maximum pitch is 220 mm. Okay. Here pitch of rivets in inner row P dash equal 220 by 2, that is 110 mm. Now this is the in fourth step you have to determine the row of pitch or back pitch. The distance between two successive rows of rivets is called row pitch or back pitch. Okay, this is the formula for determining the value of distance between the two rows. Okay, here 85 mm is the distance between two rows of rivets. Okay, for outer rows, here from this diagram you can observe this is the outer row of rivet. Okay, so the distance between these two outer rows is 85 mm. Okay, 85 mm. For these two rows, you have to determine the row pitch for inner rows is equal to 60 mm. Okay, this is the formula for inner rows for zigzag riveting. Okay, so here the value is 60. For inner rows, you have to use 60 mm. For outer rows, you have to use 85 mm. Okay, and this one also same. This is inner row, that is 60 mm for inner rows. For outer rows 85 mm. Okay, and this is the margin from here to here, margin from here to here, margin. Okay, after in the fifth step you have to determine thickness of the butt straps. Here you can observe this is the top cover plate or top butt strap, and this is the bottom cover plate. Okay, so you have to determine the suitable thickness of the butt straps. Okay, here for bottom strap you have to use thickness T1. For a top cover plate you have to use thickness T2. Okay, this is the formula for thickness of the butt strap. So the T1 value is 21 mm, T2 value is 18 mm. Okay. In last step, you have to determine the margin. Margin M equal to 1.5 into D. Here you can observe the distance between center of the rivet to the nearest edge of the plate is called margin. Okay. This is the M margin, and from here to here, this is also M. Okay. And also you can observe this is the edge of the plate. So the distance between edge of the plate and the center of the rivet is M margin. Okay. So this is the standard value. M equal to 1.5D is the margin of the riveted joints. Okay. For all type of joints, you have to consider same margin value. Okay. 1.5 into D. Okay. So M equal to 52 mm. Okay. These 6 steps are used for design of longitudinal joints. Now coming to the another design, that is circumferential joint. Before going to the design of circumferential joint, first you have to determine the efficiency of the longitudinal joint. Okay, for determining the efficiency of the joints, you have to determine PT, PS, and PC values. Okay, these are all are the values of a PT, tearing strength, shearing strength, and the crushing strength. Okay, from these three values, you have to identify the least value. Okay, so here this is the strength of the riveted joint. Okay, now this is the efficiency of the joint. Here P dash, this one is P dash. P dash is the strength of the unriveted plate. P into T into sigma T. Okay, so the least value of the PTPS PC divided by strength of unriveted plate. Okay, zeta equal to 80.8% is the answer. Now I am going to design a circumferential lap joint. Okay, in first step you have to already we determined the value of thickness and the diameter of the rivet. So you have to use the same values. Thickness T equal to 28 mm and diameter D equal to 34.5 mm. Okay. In second step, you have to design a number of rivets required for lap joint, for circumferential lap joint. Total number of rivets required for making the circumferential lap joint. Okay. So here, this is the formula for determining the number of rivets required. Here, n into pi by 4 d square into tau equal to pi by 4 d square into p. This is the formula for determining the value of number of rivets. Okay. So n equal to d square into p by d square into tau. This is the final formula. Here, capital D is the diameter of the boiler shell. Okay. Small d is the diameter of the rivet. Okay. So the number of rivets required for a circumferential joint is 90 rivets. Okay. Okay. After that, you have to determine the pitch of rivets for circumferential joints. Okay. This is the formula. Assuming the joint to be double riveted lap joint with zigzag riveting. Therefore, the number of rivets per row equal to 45. Okay. So here 90 is the total number of rivets divided by number of rows. Okay. So here we are using double riveted lap joint. So we have to use number 2 for double riveted joint. Okay. So number of rivets required per each row equal to 45 rivets. Okay. And after that, you have to determine the pitch of rivets. That means the distance between two successive rivets equal to P1 equal to pi into D plus T divided by number of rivets per row. Okay. Here, capital D plus T indicates outside diameter. Okay. From this formula, you can get the value of pitch of rivets. That is the distance between two successive rivets. Okay. From standard table, you have to select standard pitch is 140 mm. After that, you have to determine the efficiency of the joint. This is the formula for circumferential joint efficiency. Zeta C is the efficiency of the circumferential joint. P1 minus D by P1. Okay. Yeah, the joint efficiency is 75.3%. This is the distance between rows of rivets. That is row pitch for a circumferential joint. 70 mm is the answer. M is the margin. Okay. Already we discussed earlier. M is equal to 1.5 D. Okay. Okay, this is the last step for design of circumferential lap joint. Okay. Now coming to the another example problem. Design the longitudinal joint for a 1.25 meters diameter steam boiler to carry a steam pressure of over 2.5 Newton per mm square. The ultimate strength of the boiler plate may be assumed as 420 megapascal, crushing strength as 650 megapascal, and shear strength as 300 megapascal. Take the joint efficiency as 80%. Sketch the joint with all the dimensions. Adopt the suitable factor of safety. Okay, this is the given question. From this question, first you have to identify the given values. Here you can observe you have to design a longitudinal joint for this problem. Okay, you have to design a longitudinal joint for a boiler. The diameter of the boiler is capital D. Capital D equal to 1.25 meters. That is 1250 mm is the diameter of the boiler. Okay, and this is the maximum inside pressure. Okay, maximum inside pressure in the boiler. Okay, that is capital P. Capital P is the maximum pressure, inside pressure. And here assume 420 megapascal for tensile strength. Ultimate, here you can, here ultimate stresses are given. Okay, ultimate stresses are given. So this is the ultimate tensile strength. Okay, this is the ultimate crushing strength. This is the ultimate shearing strength. Okay, and the longitudinal joint efficiency is 80%. Zeta L. Okay, Zeta L, and you have to select a suitable factor of safety. Okay, from the given question, the diameter of the boiler D equal 1.25 meters, that is 1250 mm, and the pressure, inside pressure P equal 2.5 Newton per mm square. Ultimate tensile stress, that means maximum tensile stress. Maximum tensile stress equal to 420, and maximum crushing strength, ultimate or maximum crushing strength equal to 650, and maximum shear stress equal to 300. Okay, now let's consider a factor of safety, Fs equal to 5. Okay, here I consider factor of safety as 5. For design of boilers, we have to select the minimum factor of safety as 5. Now the joint efficiency is 80%, that is 80 by 100 equal to 0.8 is the joint efficiency. Okay, from given values, first you have to find out safe or permissible stresses. Okay, here these three are the ultimate or maximum stresses, but you have to use permissible or design stresses. For determine the permissible or design stresses or working stresses, you have to use factor of safety. Here this is the formula for a safe tensile stress. Safe or permissible tensile stress equal to maximum stress by factor of safety. And this is the permissible crushing stress. Permissible crushing stress equal to maximum crushing stress divided by factor of safety. This is the safe or permissible shear stress. Permissible shear stress equal to ultimate or maximum shear stress divided by factor of safety. Okay, these three are the permissible stresses. Okay, now you have to design longitudinal butt joint using these three stresses. Okay, these three stresses are the important stresses for design of longitudinal joint. Okay, in first step you have to design a suitable thickness of the boiler shell. So T, already we know the formula for thickness of the boiler shell. Okay, from this formula we got answer 25 mm is the thickness of the boiler shell. In second step, you have to determine a suitable diameter of the rivet. Here the thickness of the boiler shell is 25 mm, that is above 8 mm. Okay, if the thickness of the boiler shell is above 8 mm, then you have to use this formula D equals 6 root T. Okay, so here the diameter of the rivet equals 30 mm. From standard table, you have to select a basic size of rivet and rivet hole. So this is the standard table. From this table, you have to select a standard size of rivet. Here our answer is 30 mm. Okay, the nearest value is here, you can observe. So 30 is there. So For a diameter of 30 mm rivet, you have to select 31.5 mm rivet hole. Okay, these two are the standard values. Now, in the third step, you have to design. You have to estimate the pitch of rivets. For determining the pitch of rivets, you have to use this relation. Okay, by equating the tearing strength and shearing strength, you can get the value of pitch of rivets. The distance between two successive rivets is called pitch. Okay, so for determining the value of pitch, you have to use this relation. Here, PT is the tearing strength. Okay, PT is the tearing strength. Okay, PS is the shearing strength. Don't consider this one. Okay. Now, PT is the tearing strength. This is the formula for tearing strength. Now, for boiler joints, you have to consider double shear. Now, for this type of design, I consider 4 rivets inside, 1 rivet outside. So, total number of rivets equal to 5. N equal to 5. Okay. Here, for 4 rivets, I consider double shear, 1 rivet for a single shear. Okay. So the final shearing strength of the rivets PS equal to 3,97,500. Okay. By equating equation 1 and 2, you can get the value of pitch. Pitch P equal to 220.8 mm is the pitch of the rivets. Okay. Here you can observe for triple riveted joint with 2 unequal cover straps. Okay. There are 5 rivets per pitch length. Okay, there are 5 rivets per pitch length. Out of these 5 rivets, 4 are in double shear, 1 in single shear. That's why I consider double shear for 4 rivets and single shear for single rivet. Okay, this is the formula for single shear. This is the formula for double shear. Okay, this is the final value of shearing strength. Now, for determining the maximum pitch of the rivets, you have to use this formula. Okay, here the value of C is obtained from this table. For 5 rivets per pitch, 5, the corresponding value is 6. Okay, so capital C equals 6. Here, this is the formula for determining the row pitch. Okay, the distance between 2 successive rows is called row pitch. Okay. For inner rows, for inside rows, you have to use this one. 54 mm is the row pitch for inner rows. 54 mm. For outer rows, you have to use row pitch as 76 mm. Okay, so this is the row pitch for outer rows. This is the row pitch for inner rows. Okay, these two are the different formulas for determining the row pitch. Okay. Now, thickness of butt straps. T1, T2 are the butt straps. Okay. For bottom cover plate, you have to use T1 thickness. For top cover plate, you have to use thickness T2. Okay. Yeah, these are the formulas, corresponding formulas. The value of T1 equal to 20 mm. The value of T2 equal to 16 mm. Okay. 20 mm thickness for bottom cover plate, 16 mm thickness for top cover plate. Okay. This is the margin. M equal to 1.5 times the diameter of the rivet. Okay. So these are the important concepts for design of rivets. It is very important for exam point of view. Okay. In next class, I will explain more problems on riveted joints. Okay.